Welcome to section 4.4 of college algebra. My name is Gregory Carlson. We're going to now take logarithms and apply them to some real-life application problems. So it's important to remember that, as I've said before, the log function is the inverse of the exponential function. They're kind of the opposites of each other, and the exponential function is also the inverse of the log function. So one of the questions in your homework asks, what is the inverse of f of x equals 4 to the x power? And hopefully you remember how to find an inverse function. First, rewrite it as y equals 4 to the x. That just gets the f of x out of there and makes this a little easier. Then what's the next step of an inverse? Switch x and y. So now we have x equals 4 to the y. And then finally, you solve for y. So how would we solve this for y? What would we do? Well, the only way to get y out of an exponent is to take the logarithm of both sides. So here's what you do. You take the log, we've never done this before, you take the log of both sides of the equation. And it looks like this. The log of x equals the log of 4 to the y. Okay, now notice if you take the log of both functions, if you take the log of both sides of an equation, you have to take everything inside the equation and put it inside the log. So the entire left side of the equation went inside of this log, and the entire right side of the equation went into that log. Now, do you see how we have 4 to the y inside the log? Now we can use our log rule to pull the y down. So in other words, this becomes the log of x equals y times the log of 4. Isn't that great? And so now we're almost done. Log of 4 is just a number. It's 10 to the what is equal to 4. So you can actually, I'm going to rewrite this. We had log of x equals y log of 4. This is just a number right here, so we can divide both sides by log of 4. And they cancel. So the answer is, the inverse is y equals the log of x over 1 over log of 4, or you could put that out in front if you wanted to, but I'll just leave it like this. The log of x divided by the log of 4. Just like that. So there you go. Pretty straightforward, I hope. You could have been really clever. By the way, I used logs for this just because I think you're probably a little more familiar with them. A lot of mathematicians would use the natural log because the natural log is just nice. It's wonderful. It's based on e. And so you could have replaced all of these logs with ln's and it would have come up with the same outcome. So it's just up to you how you want to kind of do it. That'll be important to think about later. All right, so how would we find the log of 423 times 26 on your calculator? Well, you could do one of two things. This would be equal to the log of 423 plus the log of 26 because of our log rules. So what I'm going to do is I'm going to do 423 times 26, which is 10,998. Now let's just find the log of that. So if we just multiply them first and then did the log, that's going to be 4.0413. Okay? Now let's do this. Let's do the logs of them separately. Whoops. Let's do 423. Hit the log button. 2.626. And let's do 26 in the log of that. 1.41497. And let's add that to 2.626. We get 4.04097. So you can see they're pretty close, 4.0413 or 4.04097. They would have been exactly correct if I could have done an infinite number of decimal points here and here. But so there's two ways to do that problem. Okay, let's look at the next one. The formula for the pH of a solution of hydronium ions is given by this log equation. pH, you see logs all the time in pH. pH is equal to negative log of the number of H3O ions, where H3O positive is the hydronium ion concentration. Find the pH of a certain agricultural product with this concentration. So this is really cool because you're going to see how pH works. So here's the concentration right here. All right? So basically what you're going to do is just take this number and plug it into here. And then we're going to solve for pH. So here's how it's going to work. pH is equal to negative log of, just plug in your number. Okay? So the pH is equal to the negative log of 3.8 times 10 to the negative 6. Simple as that. So let's just simplify that a bit. So you could just go straight to plugging this into your calculator if you wanted to. You know, just plug in 3.8 times 10 to the negative 6. You know, just go straight into plugging that into the, and then hit log. So we see that the answer is going to be negative 5.4. So that's one way to do it, is just to throw it straight into your calculator. I'm going to use some log rules just for practice. So this will be equal to the negative log of 3.8 plus the log of 10 to the minus 6. Okay? And if you did this, you've made a mistake, because this negative right here is in front of the entire log, so we really need parentheses right here. This negative would go to this number and to this number. So that would be the negative of, now we can just do log of 3.8. So if I clear this and do 3.8 log, I get 0.57978 plus, what's the log of 10 to the negative 6? Well, you should know that that's just going to be negative 6, because it's 10 to the what is 10 to the negative 6. And that answer is just negative 6. And once we just simplify that, we're going to get the same answer as when I plugged the entire thing into the calculator. So 0.57978 minus 6 equals that. And then the negative out in front will change the sign. And so you get an answer of negative, the pH is negative 5.42 if you round to the hundredths place. So really not a lot to do there. Even this was extra steps I did just to use the log rules. So really not too bad. Remember that when you're using a log scale, every time the concentration gets multiplied by 10 is when the pH only goes up by 1. Why don't you try to do this last problem on your own, and pause the video, see if you can do this on your own, and then I'll verify it by doing it myself. Alright, hopefully you did this problem, so let's see. Here it's the same kind of thing as before. Let's plug it in. The pH of the hydronium ions is going to equal negative log of 6.5 times 10 to the negative 7. So rather than going through all the steps I did last time, I'm just going to go straight to the calculator. So I'm going to do 10 to the negative 7. So see how I did that again. 10 raised to the power of 7, and then slap the negative sign on it. Now remember, that E right there is scientific notation. That's not the natural log E, that's just scientific notation. That's 1 times 10 to the negative 7. All right, let's multiply that times 6.5. And then take the log of it. And you see why we put this negative in front. If we take, you can see that we always have a very small concentration of ions, and so as a result, when we do the log of this, we always get a negative number. So it's just a human desire to make the scale be positive. There's no reason it has to be positive, but we like to say that pH is positive, so we just slap a negative sign on there because we know this will be negative. So if we slap a negative on it, it just makes our scale be positive. So that's kind of nice. So just throw on the negative sign, and we see that the pH is positive 6.19. All right, hopefully these examples are making sense to you. Let's do, if you have any questions, please leave them in the comments. Let's go to part 2. See you there.